Hello everyone, we have here two examples of the overview of heat transfer. And for our first example, we have the inner surface of a plain brick wall is at 60 degrees Celsius and the outer surface is at 35 degrees Celsius. Calculate the rate of heat transfer per square meter of surface area of the wall, which is 220 mm thick. The thermal conductivity of the brick is 0.51 watts per meter degrees Celsius. And for our solution, we have the uh, given temperature of the inner surface of the wall 60 degrees Celsius, the temperature of the outer surface of the wall 35 degrees Celsius, the thickness of the wall 220 mm convert to meter 0.22, and the thermal conductivity of the brick 0.51 watts per meter degree Celsius. And we have here the figure to better understand or to illustrate our given. And the rate of heat transfer per square meter, we have a formula: heat over area, or the thermal conductivity of the brick multiplied to the initial temperature minus the final temperature over the thickness of the wall, or 0.51 multiplied to 60 minus 35 over 0.22. We have an answer 57.95 watts per square meter. And now for our example number 2. An exterior wall of a house may be approximated by a 0.1 meter layer of common brick. K is equals to 0.7 watts per meter degree Celsius, followed by a 0.04 meter layer of gypsum plaster. K is equals to 0.48 watts per meter degree Celsius. What thickness of loosely packed or rock wall insulation? K is equals to 0.065 watts per meter degree Celsius should be added to reduce the heat loss or gain through the wall by 80%. For our solution, we have here a figure to illustrate the given. The thickness of common brick 0.1 meter, the thickness of gypsum 0.04, the thickness of brick wall, the quality in meter, and the thermal conductivity. So common brick is 0.7, the gypsum plaster is 0.48, and the rock wall is 0.065 watts per meter degree. Now for our case 1, we have rock wall insulation used. The initial heat, we have this equation, and for our case 2, we have rock wall insulation used. We have also this equation, same to the case 1. We just add the thickness of rock wall and over the rock wall, but the final heat, we minus the 1 minus 0.8 initial heat or 0.2 initial heat. Therefore, for case 2, we have this equation and we come up to 0.1 over 0.7 plus 0.04 over 0.48 equals to 0.2 multiplied to 0.1 over 0.7 plus 0.4 over 0.48 plus x is equals to 0.065. We combine the equation in case 1 and case 2, or we have 0.1428 plus 0.0833 equals 0.2 multiplied to 0.1428 plus 0.0833 plus 15.385x, or 0.2261 equals to 0.2 multiplied to 0.2261 plus 15.385x, or I used shift solve. We have 0.0588 meter or 58.8 millimeter. Thus, the thickness of rock wall insulation should be 58.8 millimeter.